No, it only shows what's on the computer screen.
Hi, YouTube.
So we're starting a little bit late. These are notes 11 on factoring special cases. And we're at the point where we're trying to figure out how do I take 4x squared minus 25 and make it a 2x minus 5 times a 2x plus 5. So what is different about this 4x squared minus 25 than what we have factored before? Okay, no, well, we don't want to start with parentheses. We want to end with parentheses with our factoring problem. But what else is different?
There's no third.
There's no middle term. There's no x. So there's no middle term. We are missing a middle term. That helps us set this apart from our other factoring problems. There's no middle term. Also, there will always be a minus. It's always minus. When we are working with difference of squares, it's always minus because difference means subtraction. And then 4 and 25 are a special kind of number. They're not both even, they're not both odd. But what could I do with 4 and 25? What's the square root of 4? What's the square root of 25? 5. We call numbers we can take the square roots of by a special name. Trevor? Okay. Does anyone know the name for numbers we can take square roots of? We call them perfect squares. So those numbers are perfect squares. We can take the square root of each number. So our goal is to figure out, well, how do we get from here, 4x squared minus 25, to here, 2x minus 5, 2x plus 5? Well, what is the square root of 4x squared? 2x. We have a 2x here and a 2x here. What's the square root of 25? 5. We have a 5 here, 5 here. So all I need to be able to do is to take the square root of my numbers, and then it's always 1 minus, always 1 plus. 1 minus, always 1 plus. Okay, so let's take this problem again, 4x squared minus 25, the one we already know what the answer should be. And let's actually try doing the process now and see if we can do the process correctly.
Just touching my back.
Don't touch each other.
I told you, it's not okay.
We got that on YouTube, guys.
Okay, so we said we need to square root each term. We need to square root first. And this is our first option. There's actually 2 ways to solve this kind of problem. So we square root 4x squared, and we square root 25. We take the square root of both terms. So we already said, what's the square root of 4x squared? 2x. What's the square root of 5? I said the answer, not the problem. What's the square root of 25? 5. So we already know that those are part of our answer. We know that our answers look almost exactly the same, except 1 plus sign between those 2 things, 1 minus sign between those 2 things. So once we've square rooted, we can write our answer.
Wait, why is it not negative 25?
Because we can't take the square root of a negative number, so the only reason the negative tells us that we're going to have 1 positive, 1 negative sign in our answer.
Okay.
But we ignore it for the square root part. That is a good question. So now we write our answer, 2x minus 5, 2x plus 5. So the square root method when we're doing difference of squares is by far shorter. It's the quicker method. But sometimes we forget these special cases. Sometimes when we're going through a problem, we can't identify, oh, this is a difference of squares. So I can still do this problem using the box method. I can do almost any factoring problem using the box method. So according to the box method, I multiply first times last. Now in this case, since there's no middle term, negative 25 is the last term. Our middle term is the one with just an x. So we multiply 4 times negative 25 is negative 100. Then we find factors of negative 100. So again, we run into kind of something a little bit different. What should our factors add to be? If there's no middle term, what should they add to be? Okay, so Zach, you guessed 25. What other guesses do we have? What do you think our factors should add to be? Any other guesses? Remember, they're supposed to add to be the middle term. What is our middle term?
25 negative.
The parentheses in
I heard it over here somewhere, very lightly. 0. Our middle term is 0. So when we're missing a middle term, if we have no middle term, then our factors add to be 25. Or sorry, add to be 0. There is no middle term, our factors add to 0. So we need two things that multiply to be negative 100, but add to be 0. So what are some things that multiply to be negative 100? Negative 10 and positive 10. Do these add to be 0?
Yes.
Yes. So we can put them in our box. We found our factors. We put them in our box. So we have 4x squared, negative 25, 10x, and negative 10x. So now we decide what's our greatest common factor for each thing. So we say what divides into both 4 and 10? 2, including an x because they both have an x. Now notice going down we have almost the exact same thing. So it's 2x again, still positive because the top one is positive. And whoever's clicking their tongue, stop doing that. It's from that direction. That's all I know. Okay, what about the bottom row? What divides into both negative 10 and negative 25?
5
5. Is it positive or negative?
negative.
Negative because the first one, the negative 10x, is negative. If we go down, the first one this time is positive. So now we see we get the same answer. We have 2x plus 5, 2x minus 5. So whichever method we use, we get the same answer. So it doesn't matter which one you prefer. You may like the square root method better. You may like box method better. But either one will still get us to the correct answer. So let's look at our second example. Our second example looks similar to the problem we just worked with. There's only two terms. There's a minus sign. But 32 and 98, those are not perfect squares. That's a problem for us. If they're not perfect squares, this is not going to work out like we want it to. So you can see in giant writing to the side, we need to do something first. What should we always do first from now on with every factoring problem?
greatest common factor.
Look for a greatest common factor. Always. I cannot highlight this enough. Always. Look for a greatest common factor. Every single problem. So on your homework, I would do that first. I would go through every single problem and look for a greatest common factor first. And then go do the box method or square rooting or whatever needs to be done to factor it the rest of the way. So looking at this problem, what divides into both 32 and 98?
A 2.
A 2 for sure. Anything bigger, perhaps?
6.
Okay, well 4 divides into 32. Does 4 divide into 98?
Yes.
Try it. Try 98 divided by 4 and see if it comes out as a whole number.
No.
What's it come out as, Colby? 49 over 2. We do not want to use a fraction. So 4 did not work. Someone also suggested 6. But what's 32 divided by 6? It's another fraction. We can't divide 32 by 6. So we're pretty confident that 2 is our greatest common factor. Do I include any variables along with that 2? Should I have an x or an x squared with that 2? Why not? You're right. It is no, but why?
Because the other one doesn't have those.
Exactly. 98 has no x's. So we don't include an x in our greatest common factor. So we do 2, and then 32 divided by 2 is 16. We leave x squared alone because we didn't divide by a variable. And then 98 divided by 2 is 49. Okay, so I'm going to have you guys finish this problem. I want you guys to finish doing the work for this problem. And then again, we're going to submit our answers.
Oh.